Hello guys, welcome back. As you know, we have already discussed in our last video about grammar, right? I have told you what basically grammar is in the context of compiler design, which are the various tuples or properties of grammar. We have already discussed that, right? If you have not seen that video yet, please see that video once so that you can understand this video clearly. In this video what we are going to see is what is ambiguous grammar. Fine, we have already seen what the grammar is. You must be knowing, you must have understood it already. Now among grammar we are having different types of grammar like ambiguous, unambiguous, deterministic, non-deterministic, left recursive, right recursive. Fine, so these are the different types of grammar. In this particular video we are going to see what are ambiguous and non-ambiguous grammar. It is very important to know about ambiguous grammar because further we will study about different types of parsers. At that time we will study that most of the parsers are not able to parse the grammars that are ambiguous. Means this ambiguous grammar is mostly not parsed by any of the grammar. So if we are having ambiguous grammar, we must first try to convert it into unambiguous, and then and only then we can parse it easily through the parsers. So yes, what is ambiguous grammar? In one sentence you can remember that if there is any grammar for which I can generate multiple parse tree, right? For which I can generate more than one parse tree, such grammar can be known as ambiguous grammar. Now what do we mean by, in this particular video what we will see what is ambiguous grammar and how we can, if it is possible, then how we can convert the ambiguous grammar into unambiguous grammar. Now whenever any type of grammar is given and any such string is given, it is possible to draw a parse tree. Now what do we mean by parse tree? Let me show you how we can generate the parse tree. Whenever I am having grammar, generating the parse tree means what? We will start with the starting symbol, then we will parse, we will continue with all the productions that is given, and ultimately I will generate this particular string. Fine, again I will start with the starting symbol and my main aim will be to generate the given string. So for example, if taking let's take this example first. For example, this is my given grammar, this is my given string. So how we will how we will draw our parse tree? We will start with our starting symbol, that is E. So starting with the starting symbol E, let first of all I am using the production E equal to E plus E. So E equal to E plus E. Then again I can write E equal to E star E. No, I want to generate what? ID plus ID plus ID. Means I want only plus symbol. So again in place of E, I can write E gives E plus E. So I can write E plus E. Then we also know that E gives ID. So I can write E gives ID, E gives ID, and E gives ID. So basically if I want to check that whether this string is generated or not, then I have to consider the leaf node. So if I consider the leaf node, I can see that what I got in the leaf node, ID plus ID star ID, right? So you can see that what we have generated, ID plus ID plus ID, that is my required string. Now is there any other way that I can construct the parse tree and generate the given string? Okay, let's see. What I can do is E gives E plus E. So E gives E plus E. Now this time instead of expanding this E, I can expand the right side E also. So E gives E plus E. So I am expanding this one, E plus E. Now again this E gives ID, this E gives ID, and this E gives ID. So if I check my root again, then what I am getting? ID plus ID plus ID. So again I am getting my required string, that is ID plus ID plus ID. Fine. So okay, so basically first see that. So I am having one grammar, I am having this particular string. For this string, in order to generate this string with the help of this grammar, I have got more than one parse tree, means I have got two parse tree, and both of these parse trees are giving me this same string id plus id plus id. So what I can say that this grammar is ambiguous grammar. You got it? What I told, that if I am able to generate more than one parse tree, I can say that that grammar is ambiguous. So here also I am getting two parse trees, means more than one parse tree for this common string and for this common grammar. So I can say that this grammar is ambiguous. Now if you want to check one more, so this is my, again let's take the same grammar, but this time let's take this string and let's try to generate more than one parse tree if we can. So in this case, if I start with again e, so first of all let's take e plus e gives e plus e. Now again e gives e star e, so this e gives e star e. Now this e gives id, this e also gives id, and this e also gives id. So if I see the root, that what I am getting in the root, so id plus id star id, id plus id star id, I am getting the required string. Now let me try if I can get any other kind of tree or not. E gives, let me take e star e, then e gives e star e, so I have taken e gives e star e. Then let me take this one, e gives e plus e, e gives e plus e, then e gives id, e gives id. You have got, right? We are just expanding with the help of the given grammar. So if I check this also, in this case also I am getting what? id plus id star id. So in this case also I am getting the required string, that is id plus id star id. So in this case it is also proved that I have got more than one parse trees, means I have got two parse trees for the same string for the same grammar. So what is being proved, that in both the cases with the help of both the strings, both the examples, the common thing that has been proved is this given grammar is my ambiguous grammar. Fine, you have got it. Now there are actually in this case, as we know, as I have already told, that this ambiguous grammar is not suitable for our parsers. So if it is possible, we should convert this ambiguous grammar into unambiguous grammar. But actually in case of our compiler design, we don't have any particular rule that this is my ambiguous grammar, I will apply this rule and I will get unambiguous grammar. There is no such rule present. So I cannot say that I can convert every ambiguous grammar into unambiguous grammar. You are understanding? So there is no direct formula or direct method that can convert any ambiguous grammar into unambiguous grammar. So, but yes, there are certain steps, or we can with the help of our understanding, we can carry out certain measures to convert ambiguous grammar into unambiguous grammar. So again, there is no direct formula, but there are certain steps or certain logic with the help of which we can at least try to convert some of the ambiguous grammar into unambiguous grammar. See, for example, here the two examples that we are giving, that we have taken here, if you see them carefully, first of all, see here, in case of id plus id plus id, I have got two parse trees, right? But if I want to verify them, that which of them is my correct parse tree, so how we can verify? See, here the equation is id plus id star, id plus id plus id. So basically, in mathematical equations also, you must know that whenever we are having the same operator, like here we are having the same operator plus, but there is precedence will be same, right? Both are plus, so precedence will be same. Precedence or the priority of the operator is same. But in case of plus, it should be evaluated from left to right, means this should be evaluated first and then this should be evaluated first, means these two must be associated with each other. Then whatever the answer is, that should associate with this id and those two will be added, right? This is the normal method. In mathematics also we are doing the same, that from left to right we are first evaluating these two, and with the help of these two, whatever answer we have got, then we are adding this id to it. Fine. So with that point, considering that thing in our mind, what we can say, okay, one more thing, whenever we are parsing this parse tree, whenever we are checking that which operator is executed first, how we can check? We can check from bottom to top. That means whatever operator is there at the bottom, that must have been executed first, and then we are going top. Fine. So in this case, in this tree, we can say that this left id plus id is these two IDs in from left side, because we are going top to bottom, right? So if we are scanning from bottom, then we can say that, see that first of all these two IDs means from the left side, these two IDs are added first, and then with the answer this third ID is added with them. So actually this is my correct approach, because as I have seen here, from left to right I have to go. I should associate the first two IDs together first. So in the first tree it is only done, but in the second tree, if I see, if we go from bottom to top, what is happening? Second and third ID is added first, and then the result is being added with the first one. So this is actually not correct, because if we want to go from left to right, so the first way or the ideal way is to add first and second one first from the left side. So actually I can say that this parse tree is correct, but this parse tree is logically not correct. So we can say that this grammar fails. That means this grammar is ambiguous grammar, and with the help of or according to this parse tree it fails. Similarly, if I want to verify this parse tree, so here what the formula is, id plus id star id, and we all know that the priority of plus is larger than addition. So in normal mathematics also, in such cases what we are doing, first of all we are performing this multiplication, and with the result of this multiplication we are adding this first id, right? We are doing that. So in this case my correct approach should be, I should multiply the second and third ID first, and with the result I should add the first ID. So if I again consider the parse trees from bottom to top, so in this case from bottom if we see, we can see that first of all the first second IDs are added and then multiplication is done. So it is basically not correct. But if I see my second tree, from bottom to top, I can see that the second and third IDs have been multiplicated first, and then it is added with the first ID. That means this approach or this parse tree is correct. Okay, one parse tree is correct, fine, but this parse tree is wrong. That means we can say that this grammar fails. So basically this is ambiguous grammar because it fails in two cases. You are getting? There are two, we have got more than one parse tree, but among these parse trees, some of the parse tree are logically incorrect. So so basically ambiguous grammar are giving us wrong result in case of many things, like like we have seen in these two parse trees, that it is giving us the parse tree that is logically not correct. It is functioning in a way that should not function like that. So now what is the next step? We will, in such cases, we will try to convert this ambiguous grammar into unambiguous grammar. So what are the approaches? As we have seen, what we have seen, there is a grammar, there is a string. We have tried to make the parse tree. In case we are getting more than one parse tree, we can say that grammar is ambiguous grammar. Now among the multiple parse trees, it is possible that some of the parse tree is correct, but some of the parse tree is not correct. So if we take this case, that this parse tree is wrong. Now why this parse tree is wrong? Because this parse tree is growing from the right side, right? Basically in case of both the pluses, my tree should grow only from the left side. Then I can say that left ID is added first, then second ID, then third ID, whatever, means the addition should start from left to right. So in this case, why the parse tree is wrong? Because it is growing in the right side, right? You can see the difference. So logically, what can I do to make it correct? I can do that. I can restrict the growth of this tree on the right hand side. I can restrict the growth here so that the growth will only happen in the left hand side, and so it will be correct. So basically what I can do is, in order to eradicate this problem, what I can do, I can edit my grammar such that E gives E plus ID or ID. Try to understand my grammar, given grammar was this one, but here I am having E gives E plus E, both the sides we were having E. So what happened that we were able to grow the tree from both the sides. So but if we are growing it in the left hand side, then there is no problem, but if we are growing it from the right hand side, then there is a problem. So what we can do, we can restrict the growth of the tree from the right side. To restrict the growth of the tree from the right side, we can remove the E that is on the right side. So what we can do, we can convert the grammar into a form that is known as E gives E plus ID or ID. So in this case what will happen, E gives, so in this case if I want to generate the same string ID plus ID plus ID, how I can generate? I have E gives E plus ID. Now I can't grow this side, again I have E gives E plus ID. Now at last I am having E gives ID. So in this case if you see, our root of the tree is ID plus ID plus ID, means we are able to generate this string with only one parse tree possible. In this case this is the only parse tree that is possible, right? ID gives ID, ID gives ID plus ID plus ID. So this is the only tree that is possible, and this tree is giving us right answer, means the right way that it should happen. First ID and second ID will be added, and then it will be added with the third ID. So I have converted the given ambiguous grammar into this unambiguous grammar that generates only one parse tree, and that is a correct parse tree. You are understanding how we have converted? So with the help of some logic we have to convert it. Okay, now similarly we have already converted that. Now similarly this is a parse tree. Again this parse tree is wrong. Why wrong? Because according to this parse tree it is giving precedence to plus, and then it is giving less precedence to multiplication, but it should not happen. So how I can eradicate this problem? In order to eradicate this problem, again I can edit this given grammar into E gives E plus T. Like instead of writing both the sides E and giving it all the freedom to grow in any side, what I can do, I can restrict the growth in one side. So I can give E gives E plus T, then T gives T star F, and ultimately F gives ID. What will happen by doing so? By doing so, I am forcing this grammar to be E gives E plus T. So how it will be? E gives E plus T, then T gives T star F. So T gives T star F, and ultimately F gives ID. And here also okay, let me write F. So T gives F and F gives ID, and here if I write T, so E gives T, T gives F, F gives ID. Right. So what I have done here also, if I see the roots that I am getting, so the root is ID this. So what is the string that I got? The string that I got is this same string, ID plus ID star ID, right? ID plus ID star ID, and the precedence from bottom to top, if I see the precedence is ID star ID plus ID, means the precedence is given to ID and then to plus. So this is the grammar. With the help of this grammar I can restrict the growth. What is happening in this grammar? E gives E plus T or T, means first of all compulsorily I have to execute this plus, and then only I can call this T. In T I am having this multiplication, means first I am calling this plus and then I am calling this star. Then obviously from bottom to top I will be having plus star first, means this star or multiplication will always be executed before this plus. So our problem is solved here. Fine. Now I hope you have understood it. If not, yes, this is quite a logical thing. So even if you have not able to understand in the first time, don't afraid. This is actually a easy topic if you are able to understand once clearly. If you are not able to understand, please visit the video once or twice again. I hope you will be able to understand, because it is a simple concept. You have to understand the problem, that what the problem is. I have shown you the problem, the cases in which the parse tree goes wrong, why we are saying that ambiguous grammar is not correct. I have already shown you 2 examples with 2 problems, and finally we have seen how to eradicate those problems with the help of the new grammars. We have rewritten the grammar, and with the help of these new grammars we have converted that given ambiguous grammar into the unambiguous grammar, and with the help of this unambiguous grammar, the problem that we were having in the ambiguous grammar, that problem has been solved. So this is a very important topic to be understood. Once you understand this thing, then it will be very easier to understand the further topics like various types of grammar, various types of parsers and all those things. Fine. I hope you have understood. If not, please repeat the video. Try to understand the things that I have told here. Even if after that you are having any query, then always feel free to ask us. Fine. Thank you so much.